The second example that I found for a recent and important graph in the news relates to fentanyl deaths in BC. So this is a pretty serious and tragic graph that we're going to be looking at. We're going to go through the same set of questions for this graph that we did for example 1. So here's the line graph that I found. This line graph comes from an article, the title there is in quotes, by Scott Brown, and it was from the Vancouver Sun. So let's start by describing the graph in terms of trends. So I would say that during this time between 1991 to about 2013 or so, things were pretty stable or constant in terms of the number of illicit drug overdose deaths in BC. So we could say constant, or we could say more specifically roughly constant, since there's clearly some ups and downs along the way. Constant between 1991 to 2013. And then a rapid increase from 2013 to 2017. So that's describing the trends. And then maximums and minimums, we could say that the minimum number seemed to be here starting in 91. There might have been minimums before that, but in terms of the graph that we have, minimum in 1991, and other local minimums where the number dropped were around 2003, it looked like. In 2009, the numbers got a little bit lower than they had been in the past. So we could say small minimums in 2003 and 2009. Including those is pretty optional, but they might be relevant. And then maximums, we could say small maximums, sort of around 93 and 98, it looks like. In 1993 and 1998, and then largest maximum in 2017. And this is our most recent value up here. It's sort of the overall maximum of the entire graph. So what story does this graph tell? Well, it tells us that drug overdose deaths were roughly constant until about 2013. They weren't really increasing drastically in that stretch, and they also weren't decreasing drastically in that stretch. So there is clearly a problem of consistent levels of drug overdose deaths, and that problem didn't really seem to be getting much better or much worse until about 2017. Then drug overdoses began increasing very rapidly, and this recent crisis hasn't appeared to slow down, at least before 2017. Crisis has not slowed down, at least up until our data has ended in 2017. So I decided to use 2014 to 2017 to see if I could get a rate of change for this recent crisis. And so that's my line of best fit. I should have done that with a ruler, but just how I'm working here, it's hard to do with a ruler. So this is 2014 to 2017. The rise in that time, I found the highest at 2017 to be about 1,200 drug overdose deaths. And beginning in 2014, that initial point along my line of best fit was about 330, which is a rise of about 870 deaths. The run between 2014 and 2017 is 3 years. So the rate of change is equal to rise over run, 870 divided by 3, which gets me about 290 deaths per year. Now, keep in mind, this is not 290 deaths per year, because the graph is telling us the number of deaths that are happening each year. This is the increase in the number of deaths. So this is about 290 more deaths per year than previous years. So if we wanted to clarify that, we could say increasing by 290 deaths per year. So is there anything misleading about the graph? I would say no, that it's a fair graph, and I'll talk about a couple of these features. So it uses the whole graph. Has a long time scale for context. One thing that might give us pause is that it doesn't begin at 0. Now, it doesn't have to, and maybe starting at 0 isn't even reasonable, since there will never be a time, or there never has been a time, where we have had 0 overdose deaths. And so starting at 100 is maybe just choosing a convenient baseline to begin at, since it looks like just over 100 was the lowest that we have ever had in recent memory. So I would say that that is not a concern for us that makes the graph unfair or misrepresentative.